Welcome to this explainer. Today, we're taking a mobile repair concept that a lot of people find kind of complex and confusing, and we're going to completely demystify it. We're going to transform impedance measurement into your absolute ultimate diagnostic superpower. So if you've ever felt totally lost just staring at a circuit board, you are definitely in the right place.
Okay, let's dive right into this incredibly common frustration. Picture this: a completely dead phone comes into your shop. It's totally lifeless. Where do you even begin? I mean, do you just start randomly removing and testing 20 different components, hoping you somehow stumble across the broken one? Of course not. That wastes hours of your valuable time. There's got to be a faster, smarter, more surgical way to find exactly where that fault is hiding. And trust me, there is.
Here's our roadmap for today. Number 1, what is impedance measurement? Number 2, the correct measurement method. Number 3, how to read the results. Number 4, deeper understanding of shorts. Number 5, practical application, speaker fault. And finally, number 6, common mistakes for beginners. Let's jump right in.
All right, Section 1. What is impedance measurement?
Let's start by redefining what we're actually talking about when we say impedance in the mobile repair world, because it's actually a bit different than what you might have learned in physics class. Scientifically speaking, impedance is just the resistance of a circuit to current flow. But let's toss that textbook definition out the window for a second. In practical mobile repair, it's a very specific technique. We're using the buzzer mode on our multimeter to test the precise relationship between a specific path or a line on the board and the ground. We're not hunting for a highly precise digital resistance number to write down. Instead, we're quickly testing the overall health status of a path relative to the ground.
So, how does this actually work under the hood? Well, when you set your multimeter to buzzer mode and touch those probes to the board, your multimeter's internal battery pushes a tiny safe voltage right through the path you're testing. The multimeter then measures the current that manages to return back to it. Now, why is this so brilliant? Because every single circuit in a phone, whether it's the main VPH power line, a speaker circuit, or a backlight path, has a unique, normal baseline behavior when it interacts with the ground. If you test a path and that returning current doesn't match its natural baseline, boom, you instantly know you've got a problem. Any change in this relationship points straight to a short circuit, an open cut path, a leakage, or a blown component. Moving right along to Section 2, the correct measurement method.
Now, theory is fantastic, but execution is absolutely everything. Knowing exactly how to set up your tools before you ever let a probe touch that motherboard is crucial. Step 1, set your multimeter to buzzer mode. Step 2, and listen up because this is where a lot of beginners get tripped up, you must place the red probe on a ground point. That could be a metal shield, a gold grounding line, or even the metal body of the USB port. Step 3, take your black probe and place it on the beginning of the path you actually want to test. Notice that reverse logic there? We anchor the red probe on the ground and use the black probe to explore the active circuitry.
But wait, hold on, before you touch anything. If you take away just one thing from this entire section, please let it be this unbreakable rule. Never, ever measure impedance with a battery connected to the motherboard. It has to be completely disconnected. If there's external power running through the board while your multimeter is trying to send its own tiny measuring voltage, your readings are going to be completely useless. Plus, you literally risk damaging your tools or the board. Power off, battery disconnected, always. No exceptions.
Okay, Section 3, how to read the results.
Let's decode the 3 distinct languages your multimeter actually speaks: numbers, beeps, and absolute silence. First up, you might get a digital reading with no beep. This is great. It means there's a normal, healthy resistance to ground. The path is positive and doing its job properly, like a healthy IC power feed or a signal line. Second outcome, you get a loud beep only. This means there is very low resistance to the ground. Now, if you're testing a ground line, a beep is exactly what you want. But if you're testing what's supposed to be a positive line, like a main battery path, and it's screaming at you, you've got a short circuit, probably from a blown capacitor. And the third outcome? No beep and no reading whatsoever. This either means the path is completely cut open, or you're just probing an unused testing pad. If it's a critical path, that blank reading means you found a broken trace, and you'll need to compare it to a healthy board.
Let's dig a little deeper here in Section 4, deeper understanding of shorts. Now that we've got the basics down, we need to add a little nuance. Because you know what? Not every single beep is a villain out to destroy your motherboard. You have to be super careful with complex lines like vCore, VIO, and CPU paths. These data-heavy lines often have dozens of capacitors tied directly to them.
Because of all that massive capacitance, your multimeter might actually give a natural light beep and a medium digital reading. And guess what? That is completely normal behavior for those specific lines. This is way different from a true short circuit, which will practically scream at you with a really loud, aggressive beep, show a reading at or very near absolute zero, and will immediately draw massive amps if you hook it up to a DC power supply. Knowing the difference between that natural CPU beep and a true destructive short is absolutely essential.
All right, let's make this real. Section 5. Practical application. Speaker fault.
Let's take all of this awesome theory and drop it into a real-world scenario. A customer walks into your shop, hands you a phone, and says there's absolutely no sound coming from the speaker. Let's fix it. Step 1. Always confirm the physical speaker component itself is actually working before you go blaming the motherboard. Once you know the speaker's good, Step 2. Crack open your board schematics and locate the 2 matching paths that drive that speaker audio. Step 3. Using that buzzer mode technique we just mastered, measure the impedance of each of those 2 paths relative to the ground. Step 4. Compare your results. If one path gives you a normal, healthy digital reading, while the exact matching partner path gives you a loud, aggressive beep, well, there you go. You've instantly identified a short on that specific damaged line. It's like a giant puzzle, and you just found the exact missing piece.
Check out that number, 20. That is the number of tiny, fragile, extremely annoying surface mount components you just completely avoided unnecessarily removing, testing, and resoldering manually. By simply measuring the impedance of the paths to ground, you successfully isolated a complex motherboard fault in, maybe 1 minute of diagnostic time? That right there is the true power of this technique, a real game changer.
We're almost to the finish line. Section 6. Common mistakes for beginners. Before you grab your tools and start probing every single board in sight, let's make sure you don't fall into the common traps that ruin diagnostics. Number 1, do not reverse your probes. Remember our golden rule, red probe goes to ground. Number 2, as we stressed earlier, do not ever measure with the battery still connected. Just don't do it. Number 3, and this is a massive one, never rely exclusively on your ears. Do not just listen for the beep. You absolutely must look at the digital reading on the screen so you can tell the difference between a dead short and a natural low resistance. And finally, number 4, failing to compare a suspicious path with a known healthy identical board or schematic. If you get a weird reading, your absolute best diagnostic tool is simply comparing it to what normal is supposed to look like.
This quote really hits the nail on the head. It perfectly captures everything we've talked about today. Mastering this specific relationship between the path and the ground changes the entire way you approach mobile repair. It pulls you away from just guessing and crossing your fingers, and it turns you into a highly accurate, analytical problem solver. Literally, this is the dividing line between an amateur who hopes for the best and a true professional who knows exactly what they're looking at.
So what does this all mean for you? Well, we've officially decoded the secrets of the beep, the numbers, and the silence. You know exactly how to set up your tools, and you know the exact pitfalls to avoid. So the next time a completely dead, mysterious board hits your bench, you're not going to panic. You're going to grab that multimeter, you're going to put that red probe straight on the ground, and you're going to let the impedance guide you right to the fault. Are you ready to get testing and find those hidden shorts? Thanks for hanging out with me for this explainer, and happy repairing.